Hello, my dear friends. Welcome to the Sharpage update. Deepak Tiwari is here. Friends, in previous video, I have explained you the meaning of electric field, intensity of electric field, and electric dipole. Now, in this video, I am explaining the calculation of electric field intensity in and on position. Electric field in and on position due to an electric dipole. So friends, this position means and on position is also known as axial position or longitudinal position. Now, what is the meaning of axial position or and on position or longitudinal position? So, I am drawing a figure to explain the and on position. Suppose we have two equal and opposite charges plus q and minus q, and these two equal and opposite charges are kept at very small distance to L. So this is the separation between these two charges, and the separation between these two charges is represented as 2L. Suppose this is a point A and this is a point B. So AB is the electric dipole, means when two equal and opposite charges are kept at very small distance, then this system is known as electric dipole. So friends, this is the axis of this electric dipole, means the line which joins the two charges, that is plus q charge and minus q charge, is known as the axis of this electric dipole. Now friends, and on position or axial position or longitudinal position means when a point where we have to determine the electric field intensity is on the axis of this electric dipole is known as the and-on position. Now friends, the and-on position or axial position or longitudinal position is the position of a point at which we have to find the electric field intensity is on the axis of this electric dipole. Now friends, if we extend the axis of this electric dipole and let P is a point on the axis of this electric dipole where we have to find the intensity of electric field. So the position of this point is known as and-on position or axial position or longitudinal position. Now, this is the midpoint of this electric dipole, means O is the midpoint of the axis of electric dipole AB. And the distance between the point O and point P is represented by R. Now, as we know that at the point where we have to find the electric field intensity, we have to keep a unit positive test charge on that point. So, if we put a unit positive test charge at point P, then the unit positive test charge experiences a force of repulsion due to the plus q charge. So, direction of electric field intensity due to the plus q charge will be in this direction. Let the intensity of electric field due to the plus q charge is represented by E, then the direction of electric field intensity due to the plus Q charge will be in this direction, because there will be a repulsive force, and the electric field intensity due to the minus Q charge is represented by E2, then the direction of intensity of electric field E2 due to the minus Q charge will be in this direction. This is the direction of electric field intensity E2 due to the charge minus Q, because there will be a force of attraction between the unit positive test charge kept at point P and the minus Q charge. Now, here you can see in this figure, AB is an electric dipole. The length, or you can say that the separation of the plus Q charge and minus Q charge is represented by 2L. O is the midpoint of this electric dipole. P is the point on the axis of this electric dipole where we have to find the electric field intensity. So the position of point P is known as the end-on position or axial position or longitudinal position. And the distance between O point and P point is represented by R. Now, as we know that the electric field intensity at a point due to a source charge Q is E equal to 1 upon 4 pi epsilon 0 into Q upon distance square, where Q is the force charge and R is the distance between the two test charge and the point where we have to determine the electric field intensity. And 1 upon 4 pi epsilon 0 is the constant of proportionality, and this force charge is kept in the medium of air or vacuum, and the system of measurement is taken as SI system. Now, at point P, the electric field intensity is represented by E1. So, due to the plus Q charge, the intensity of electric field at point P will be E1 equal to 1 upon 4 pi epsilon 0 into Q divided by. Now, the distance between plus Q charge and point P where we have to find the electric field intensity is AP. So, the distance means AP square. Now, in this figure, as you can see, O is the midpoint of the axis of this electric dipole. So, the length AO will be equal to L. Now, we have to calculate the distance AP. So, distance AP will be OP minus OA. It means AP equal to R minus L. So, the value of E1 equal to 1 upon 4 pi epsilon 0 into Q upon R minus L whole square. You can see by the figure. Now here E1 is a vector quantity, means intensity of electric field is a vector quantity. So the direction of this electric field intensity will be in the direction of AP, along the direction of AP. You can see by the figure that this is the equation number 1. Now, the electric field intensity E2, which is due to the charge minus Q at point P, is E2 equal to 1 upon 4 pi epsilon 0 into Q upon. Now the distance between P and minus Q is dP. So here Q upon dP square. And the direction of this electric field means E2 will be along the PB. So the direction will be along PB. Now, BP distance will be R plus OB, means R plus L. So E2 equal to 1 upon 4 pi epsilon 0 into Q upon R plus L whole square. So this is equation number 2. Now you can see by this figure, E1 and E2 both are along the same line but in opposite direction. Now you can see by the equation 1 and equation 2, E1 means magnitude of intensity of electric field E1 is greater than magnitude of electric field intensity E2, because you can see here R minus L whole square, and in this equation there is R plus L whole square. So in this equation, denominator is less than this. So the magnitude of E1 will be greater than the magnitude of E2. Now let the resultant electric field intensity at the point P due to this electric dipole is represented by E. So E equal to means magnitude of resultant field intensity E equal to magnitude of electric field intensity E1 minus magnitude of electric field intensity E2, because E1 and E2 both act along a line but in opposite direction. So the resultant of these two intensities will be the subtraction of E1 and E2. Here, by the first equation, we can substitute the magnitude of electric field intensity E1, and by the second equation, we can substitute the magnitude of electric field intensity E2. So here, 1 upon 4 pi epsilon 0 into Q upon R minus L whole square with the help of first equation, minus 1 upon 4 pi epsilon 0 into Q upon R plus L whole square with the help of equation number 2. So the magnitude of resultant electric field intensity at point P due to this electric dipole in and-on position or axial position or longitudinal position will be E equal to, here Q upon 4 pi epsilon 0 can be taken. So Q upon 4 pi epsilon 0. Now 1 upon R minus L whole square minus 1 upon R plus L whole square. So 1 upon R minus L whole square minus 1 upon R plus L whole square. So by calculating this bracket, we can write here E equal to Q upon 4 pi epsilon 0 4 R L upon R square minus L square whole square. मैंने यहाँ पर ये टर्म डायरेक्ट लिखी है, कैसे? R minus L whole square into R plus L whole square will be the LCM of this bracket, and here in numerator there will be R plus L whole square minus R minus L whole square. So with the help of identities A plus B whole square and A minus B whole square, if we open the brackets, then we get 4RL. And in denominator, R minus L into R plus L whole square. So A minus B, A plus B equal to A square minus B square. So here R square minus L square whole square. So E equal to Q upon 4 pi epsilon 0 4RL upon R square minus L square whole square. अब यहाँ पर आपको एक विशेष ध्यान रखना है कि इस 4 से इस 4 को कैंसिल नहीं करना है, क्योंकि we know that the value of 1 upon 4 pi epsilon 0 and the value of 1 upon 4 pi epsilon 0 is equal to 9 into 10 to the power 9 as I have told you in the previous videos. So आपको यहाँ इस 4 से इस 4 को कैंसिल नहीं करना है. Now, as I have told you in previous video, the moment of electric dipole means electric dipole moment. Electric dipole moment is represented by P, and the meaning of electric dipole moment is the product of the magnitude of one charge and the distance of separation between the two equal and opposite charges of an electric dipole. So, as we know that the electric dipole moment is 2ql. ये मैंने आपको पिछले वीडियो में बताया है. So, with the help of this relation, we can write here equal to 1 upon 4 pi epsilon 0 into. Now, Q into 4 into R into L. So, we can write here 2 into 2ql into R divided by R square minus L square whole square. So, 2ql will be the electric dipole moment, and electric dipole moment is represented by P. So, E equal to 1 upon 4 pi epsilon 0 into 2 P R upon R square minus L square whole square. Newton per Coulomb. Newton per Coulomb is the SI unit of electric field intensity. Now friends, if the point P is very far from this electric dipole, then the higher powers of L can be neglected, because if point P is very far from this electric dipole or from point O, midpoint of an electric dipole, then L is much less than R. So, the higher powers of L means L square can be neglected as compared to the R square. So, by neglecting the L square, we get E equal to 1 upon 4 pi epsilon 0 into 2p R upon R to the power 4. Here, the higher power of L is neglected because L is much less than R. So, the value of L square can be neglected as compared to the R square. So, the final relation for the electric field intensity due to an electric dipole in and on position or axial position or longitudinal position will be E equal to 1 upon 4 pi epsilon 0 into 2p R upon R to the power 4. So we get 2p upon R cube. Newton per Coulomb. So this is the magnitude of electric field intensity at point P due to this electric dipole, and the point P is at the axis of electric dipole, means the position of point P is and on position or axial position or longitudinal position. Now friends, in next videos I will tell you how we can calculate the electric field intensity in broadside on position or neutral axis position or transverse position. Till then, goodbye. Please like and subscribe the channel, the Sharpage Update.